Hello and welcome to this video on the historically favored means of making pharmaceutical products like the influenza vaccine, eggs. Yes, eggs may seem like they are only good for food, but they have many other uses. This can range from clearing wine to creating vaccines. They are a much more versatile product than you might imagine. The choice of eggs might seem odd, but there are some very good reasons why they are used and why they've been used for nearly a century and in some places still are used. Eggs, and generally chicken eggs, are used for a number of reasons. The biggest are economy and ease of use. Chicken eggs are available in bulk for relatively little cost. Each is roughly the same shape, size, and weight. That gives you consistency. The method is also relatively straightforward, meaning lower skilled labor is needed to perform a repetitive and simple task. The process begins with fertilized chicken eggs. Fertilization is key, as the eggs must have living cells for the virus that is to come. The fertilized chicken egg has been fertilized and cells start to proliferate. This means you go from 1 cell to 2, then 4, 8, 16, and so on. This is the basis of the vaccine. These eggs must be supplied daily to ensure continuous production. If the egg tops are removed, just like you would for a hard-boiled egg, ideally it leaves the membrane intact, but not always. Other methods remove this need entirely and can inoculate the egg without ever having to leave any lasting damage to the shell. From here, a small amount of the selected influenza virus strain is inoculated into the egg yolk. As it has living cells, the virus can hijack the cellular machinery to replicate itself. Inoculation can be done by use of a seed or injection of a liquid culture. This creates a mass of new viral material and live virus. The egg is left to incubate for several days in this state. Often a period of roughly 3 days is used. Eggs are then chilled to somewhere between 2 and 8 degrees Celsius. This is useful as it constricts vessels within the egg and it makes the next steps that much easier. After your initial period of roughly 3 days, the yolk is withdrawn from the egg, and this will be rich in virus material that can be used for making vaccines. The rest of the egg is then destroyed as a biologically hazardous waste material. The yolk, once it's extracted, is processed in a number of ways. One is to remove the non-virus material, and this is done where possible. The second is to isolate and purify the virus. The primary goal here is to ensure that what you're getting out of it is to get the virus out and as little other material as possible, ideally deactivating it in the process, but not necessarily so. Fundamentally, the egg yolk extract that has been filtered and refined is heated until the virus is killed, and this creates the deactivated virus vaccine, or at least it used to be the case. Newer production methods have shifted from the use of heat to the addition of formalin to the egg and then the extraction of the yolk. This allows for a more efficient and fewer difficulties involved in the production of the necessary products. Once you filter and refine these, they are tested by agencies like the FDA and the manufacturer's own quality control and assurance prior to proceeding to the next stage. The deactivated virus can be further filtered and processed. From here, you are left with a concentrate, and this is what is then packaged for distribution. What generally happens to get this concentrate is that it's put into a centrifuge, and it is spun until you can take what is the bulk of the material extracted from the eggs and separate out the part that is virus and the part that is not virus. From here, you should wind up with a small band of material in the centrifuge tube. This is generally separated from everything else with sucrose. By having this separation, you can extract everything that's unwanted and everything that is wanted. It's then washed with Triton detergent, which further helps to break up the material and separate into what is wanted and what is not wanted for another attempt at centrifugation. This further separates that material based on size this time, and by having large particulates, which aren't any use in a vaccine, and the addition of more formalin, you can ensure that any virus left over, and it's only virus at this point, is deactivated and is safe. After you've done all this, the product is passed through something called ultrafiltration, and this is pretty much to ensure that only the small monovalent areas or the antigens that are going to give the vaccine its effect are present. It sterilizes it and it filters it, leaving you with the best safety and best possible vaccine. As you can imagine, there is at least one big problem with using eggs for vaccine development. They are not available year-round. There is often a 4-month gap where eggs are not produced, and so fertilized eggs cannot be sourced. There have been efforts to correct this, but this has also led to much higher hurdles for production. Most chickens in this sort of situation are treated as part of a sterile pharmaceutical factory, not so much as animals. They must be housed in an isolated environment and cared for by veterinarians and monitored. This increases the cost and difficulty in developing vaccines. This particular barrier may not seem obvious as eggs are available year-round in grocery stores, but that is a combination of storage methods and the way farming of eggs is done. These are outside the scope of this video, but understand that fertile eggs are available on a different cycle to unfertilized eggs, and what is needed for the production of something like influenza vaccines is very different to what is needed for the grocery store. Unlike the old and traditional methods of most egg production methods of influenza vaccines that were done by a person, there has been a shift where influenza vaccines are largely made by automated systems now. And this is one of the reasons why the standardization of an egg is so convenient. Even with automation, the biggest part of making a vaccine, and even if we are talking about this as produced using chicken eggs or via other methods, the biggest barrier is not the production, which takes about a week, but the regulatory hurdles and safety monitoring steps. This is not something that can be streamlined any further by the manufacturer of vaccines. They are limited by the fact that some steps will take time no matter what they want. In the future, it is likely that cell culture will supplant eggs as the vaccine manufacturing method of choice, but for now, chicken eggs are the go-to option, simply because they are economical, reliable, and predictable, something that many manufacturers of vaccines are very comfortable with using because they've done so for a long time now. Thank you for watching this video. If you have found it interesting, consider liking, sharing, and subscribing. Please post any comments, questions, or suggestions you have below.